Okay, so let us have here an example. Uh, Now in this equation, you have y, or the fourth derivative of y, and then here the third derivative, and then the first derivative. So we can write here in this equation, instead of fourth derivative, we can just have to the power of 4, and then to the power of 3, power of 1. So from here, we can isolate, or we can factor out lambda, which is obvious that we can move it out. So here, when you move out or isolate lambda, from 4 it becomes 3, here from 3 becomes 2, and then here, of course, it remaining is only 2. So the root, okay, here we already have one root is equal to 0, lambda 1. But this one, what are the roots? So the hint is to try for a number, let us say 1 or negative 1, as another root. Okay, so if you have this root negative 1, so you have a factor of lambda plus 1. If you're going to divide this by lambda plus 1, you can get this answer. You do it by long division, you can get this answer. In other words, we copy this one, you have lambda plus 1 multiplied by this one will give you this equation. So meaning these are your factors. Okay, and from here, this one, we can already get the factor. Okay, let us continue. Okay, so this one could not be easily be factored out. Okay, we can only do this. I've tried it already. We can only do this by the quadratic equation. We can come up this one. Let's say in the quadratic equation, you have ax squared minus bx plus 2. Okay, you have a here is equal to 1, b is equal to negative 2, and then c is equal to 2. The formula for the quadratic equation is minus b plus or minus b squared minus 4ac over 2a. Okay, so minus b here is equal to 2. Okay, minus b, okay, b is minus 2 and negative becomes positive, plus or minus b squared is 4. Okay, minus 4ac, 4 times 1, and c is equal to 2, okay, over 2a, which is 2. That's why you have this on 4 and 2 is negative 8, and 4 becomes negative 4. Negative 4 is just like you have negative 1 and 4. So negative 1 is equal to the imaginary, which is I. Square root of 4 is 2. So you have this value simplifying further. Okay, so here it's easy to identify that alpha is equal to 1 and beta is also equal to what? 1. So we have here the roots. First root is equal to 1. Second root is equal to negative 1. Okay, this one you move to the right becomes negative 1. And then the third and fourth root is equal to, okay, this one. Okay, so this one is just a what? This is just a distinct case. This is for case 1. C1, actually you have here 0x, but this one becomes 1, so you only have here C1. Okay, C2 to negative x. Okay, and then here this one is already for the complex. Okay, you have C3 and then C4. Okay, C3 and C4 cosine beta x, which is equal to 1. Similarly here, E, you have here E, okay, alpha x. Here alpha is also equal to 1. That's why here you just write here EX. Okay, so that's for case 3. Okay, and then for case 4, if you have an equation coming from quadratic which are complex, and then you have multiple values, then you do this with this application of case 4. Okay, so for example, you have this equation. So again, the same approach. From 5, you have here 3, and then you have here 1. Okay, here it's obvious again that we can factor out 1 lambda. So what remaining here, from 5 becomes 4, from 3 becomes 2, and then you have here 81. This one you can easily factor out. It is just like x squared plus 810 plus 81. So the factor here is x 81 is 9 and 9 plus. Okay, so you have here x plus 9 squared. So if your x here is equal to lambda squared, so you just have to substitute here lambda squared plus 9 squared. So you have this one. So it's very obvious that you have here the first root, okay, is equal to 0. Second root, 2 and 3, okay, which is equal to plus or 3. This is lambda squared, becomes negative 9, okay. So it's obvious that you have lambda 1, 2 and 3. 2 and 3. You have here negative 1 and 3, or plus or minus 3i imaginary. That's why you have this one, okay. But since this is squared, so meaning this is multiple values, okay. So from the equation, you have here c1, which is actually of 0x. This becomes this 1. That's why you write only c1. And then since this is multiple, you have for c2 and c3, c2 and c3x, then you just substitute cosine x for cosine x, okay, right here. And then for sine x also, actually sine bx, beta is this one, beta is equal to 3, okay. Then you just continue with the sequence from c2, c3, and then c4, c5. Okay, so what's interesting here that you have to check, you have c2 and then c3x. This stands for the repetition, okay, repetition. So the roots here are the same, multiple, they're the same, okay. Also here for sine x, here for cosine x, and here for sine x, okay. So that's all for the case 3 and case 4 of this higher order differential equation.